Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, we will continue talking about two-factor ANOVA, and we will talk about moving on from testing the full model into testing the specific model components, also known as the main effects of ANOVA. So we talked in the last video lecture about testing the full model and kind of where we might go from there. This flow chart is going to show where we might go from there once we've tested the full model. And using this violent video game example, we tested the full model and saw that in the full model, the overall f-test was in fact significant. So now we would move on from testing the full model to testing the main effects of each individual predictor. So there are going to be two significance tests for this. There's a main effect significance test for gender and a main effect significance test for video game condition using our example. And so we're testing the unique influence of each predictor on the outcome. So our null hypotheses are just going to be like they were in Way ANOVA, and that's for each predictor that those group means are equal. And the alternate hypothesis would be that at least two of the means differ, or if there's only two means, that the two means do differ. And we're going to go through the significance testing for this in exactly the same way that we do for the overall model, using the F statistics calculated by the mean squares for each predictor and the mean square error. So let's take a look first at the gender main effect, assessing the gender main effect. So here are the estimated marginal means for gender, and we can see that there is a little bit of a group difference here, the difference between 3.33 and 4.667 for the means on aggression. And if we take a look at a profile plot, which is the actual plot of the estimated marginal means of aggression separated out by gender, we can see that there does appear to be, looking at this plot, a little bit of a difference between males and females. So the F-test for gender is evaluating whether boys and girls have different levels of aggression, because we've only got two groups. So when we calculate this F-test, we use that mean square, which we calculated, which we show the calculation of for the predictor, divided by the mean square error, and that gives us an F statistic of 3.95. And this is a non-significant F-test. And so a non-significant F-test implies that sampling error could be responsible for that observed gender difference. The p-value is 0.057, so it's really just on the cusp of that p equals 0.05 cutoff, but it is telling us that the gender difference is it's not significantly different. It's not large enough to be a meaningful difference. And here's where we would find that information in the SPSS output. So now let's take a look at the estimated marginal means for the video game condition. So now we're going to be moving to looking at the main effect of a video game condition. And if you remember when we talked about the component R squared values and we looked at them, it really did look like gender was not accounting for very much variation in aggression, but that video game condition was accounting for a lot more variation, a lot more of the variation in aggression. So if we look at these estimated marginal means, it does look like the violent video game condition has a higher mean than control or nonviolent video game conditions, which is what we would expect to see, right? We would hypothesize that for the kids playing violent video games, they're going to be exhibiting more aggression. And looking at these profile plots, again, these are the plots of the estimated marginal means of aggression separated out by a video game condition. These profile plots kind of show that as well, that violent video game condition seems to have a little bit higher average aggression than the other conditions. So we're going to go ahead and calculate the F-test for the video game main effect. And this is going to evaluate whether the three experimental conditions produce different levels of aggression. Now, this F-test, because we've got three groups here, when we calculate this F-test, this is telling us that at least, if this is a significant F, that's telling us that at least two of the groups have different levels of aggression on average. And this F statistic, again calculated using the mean squares, is 9.64. And it is statistically significant, and that suggests that the conditions do produce reliable differences in the mean levels of aggression. And here is where we would find that on the SPSS output. So now that we've calculated those F tests for the main effect, we can come to some conclusions about the data generating model. And if you recall, when we talk about the data generating model, we've got some mean, some population mean, each score equal to some population mean plus the effect of predictor 1 plus the effect of predictor 2 plus some error. And what we can conclude about this after looking at our F tests is that gender does not need to be a part of this model. Right? Gender is not a part of the data generating model in that there is no difference in aggression for males and females when we just take that predictor into account. And so we've zeroed that out here in that data generating model. And so the data generating model is really only going to include the influence of predictor 2. That's the difference between control, nonviolent, and violent video games. So if we took a look at the data generating model as a line graph, really the male and female conditions would be laying right on top of each other because we're not separating out by males and females anymore. I've separated them slightly so that you can see that they're still there, but really we're considering this to just be one population that has kind of different means on the video game conditions. This concludes the 5th lecture on two-factor ANOVA, and in the next and last lecture, we will discuss how to compute pairwise comparisons if you find a significant main effect in two-factor ANOVA.